All right. So, where do y'all want to start? Do you have particular questions that you want to start with? Then it's going to become a big long list of questions. So we can start with that if you like. Particular questions that you want to start with? I have all the exams we can take a look at.
There's a concept question.
Uh-huh.
I'm confused about it might be on, I think it's this one, where it asks which statement is true about, it's like UK.
Right, and you're going to have some questions like that. I like those questions. I give you a series of statements, you have to pick out the true ones. So let me see if I can find that question. There's this one about the force due to friction. Right here. Is that what you mean?
Yeah, no, that's A, right? It's just the force that goes. No, it might not be this test. I'll find it.
Okay, you find it.
It's on this test, number 11. Can you explain the graph? How put it after D, but it's A? Can you explain?
I can tell you why it's not D. Because if we look at D, the slope of this is positive or negative? It's positive, right? And so if the slope is positive, the acceleration is positive in the y direction, but that can't be true. So it can't be D because it has a positive slope. Let me show you. This is what I'm looking at, something like this. Initially, the y velocity is big and positive, then it gets smaller, and then it's 0, and then it gets, so it begins out big and positive right here, and then it gets to 0, and then it gets big and negative. All right? What else? Particular questions, or we can just sort of scroll through them if you like. Number 22. Matt, were you asking a question? Okay. Okay, so this is a kinematics question, but a little bit of Newton's laws thrown in. So I want to know the x position of this. I want to know what is x equal to. And I know that that's equal to v naught t plus 1/2 at squared, right? So if I know t is equal to 4. I know v naught, because it's initially at rest, is equal to 0, so this thing goes away. In fact, this whole term goes away. And I know that my acceleration, well, I need to find my acceleration. So my acceleration I don't know right off. So I say a is equal to f over m, and then that's equal to 10 newtons divided by the mass, which is 2 kilograms. So my acceleration is positive 5 meters per second squared. You with me on this? Yeah? So now, yeah, now I can take it here and I say x is equal to 1/2 of 5 times t squared. T is 4 squared, so that's 8 times 5, or 40 meters. Okay? There's something I wanted to tell y'all right off. Okay, what else?
Can you explain number 26?
Number 20?
Look back in the video.
It what?
It cut off.
What do you mean it cut off? Really? Okay, so a block sits on an inclined plane. What happens to the normal force as the angle of the inclined plane increases? Interesting question. So I like to think of this in terms of increments, that if I have an inclined plane, what happens to the normal force of an object that sits on that plane as the angle increases? And so these are planes with increasing angles, right? Here the angle is 0, here it's something bigger, bigger again, and here it's 90 degrees. Now remember, the normal force, if it's just sitting on the surface, is equal to what? Is equal to the weight, assuming there are no other forces. Now if I'm pushing on it, then that increases the normal force. Or if I'm lifting up on it, that decreases the normal force. We can look, there's a problem just up the way. So here, what happens to the normal force? I know it's equal to the weight here. What happens to it here? It decreases. Now remember, the normal force is the force that's perpendicular here, and it's my weight is towards the earth, and so the normal force is equal to some component of the weight. Here, the normal force is equal to the weight. But here, the normal force is equal to a component of the weight. What is the normal force here? It's 0. Because the weight isn't in the x direction at all. It's all down. So the normal force here is equal to 0. Unless I was actually pushing on the object with a certain force, then the normal force wouldn't be 0. You hear what I'm saying? That's a separate problem. But let me just make sure that's clear. That if I have a wall, for example, with an object on it, and I'm applying a force here, then the normal force, Fn, is equal to whatever that force is that I'm applying to it. So if I have an object like this, and I apply a force in this direction of 2 newtons, that means that the normal force is 2 newtons. The normal force in this case has nothing to do with the weight, because the weight is acting down, but the normal force is that force. Whatever I'm pushing in is the reaction force to that. That's important. Okay? You understand what I'm saying? Okay. So here, the normal force decreases. Okay? Is there another question on this test? Can we look at this problem, number 25? I know it's on the... it's just an important question. Because it's a little bit different. I don't remember... I'm not saying that because it's on the exam, but there are questions like this on the exam. It's a little bit different from our inclined plane, but with 2D forces still. So I have this object, and I have forces acting on it. The force of 50 newtons is right here at 30 degrees, and I have a weight, Fw, and I have a normal force, Fn, and I have a frictional force, Fk. This is my 50 Newton force here. I'm going to go ahead and resolve those forces onto their x and y axes. This is going to be 50 sine of 30. This is going to be 50 cosine of 30. This is going to be Fk. And then this will be Fn. I'm sorry. Yeah, 50 sine. That's right. Yeah. Not Fn. This is Fw. Sorry. And what I want to know is the acceleration. So in order to find the acceleration, I'm concerned with this, with the x-axis, right? Because I know the sum of the forces is equal to max. And that's what I'm looking for. I'm looking for an acceleration in the x direction. I'm looking for this value. So I say 50 cosine 30 minus Fk is equal to the mass times ax. But I don't know Fk. And that's where these friction problems get complicated, that you have to find out what Fk is. But in order to find Fk, I have to know what? Fn, right? I have to know the normal force. So I have to take a little aside to find out what is Fn. I'll do it in red here. And I know from the sum of the forces in the y direction that Fn plus 50 sine 30 minus the weight, which in this case is 40 newtons, that's equal to 0. And so I can find Fn. I don't know, Fn is 40 minus 25, 6, 15. And then I can find Fk. So Fk is mu, that's this 0.5 times 15, or 7.5 newtons. So I would take this and plug it in there. The 7.5 came about. Fk is mu times Fn. That's 0.5. That's given up here. Times 15. That's my normal force. So it's 7.5 newtons. And then I put that 7.5 in here, and I solve for AX. Like this would probably, if you had a problem like this, it would probably be one of the more difficult problems. There are several steps that have to occur. But you still need to be able to do it in a few minutes, 3 to 4 minutes, no more than that. And then other problems you need to be able to do in less than a minute, but just the time that it takes you to read them, you need to be able to answer them. Okay? I know that seems difficult. I know it seems like, gosh, nobody can do that, but I know that you all can do that. Alrighty? Any other problems here? I'll skim through, but if you have particular problems you want to work, I have all the exams. We can look at them. There's some inclined planes. You're going to see a problem like 24. You'll probably see a problem like 23. Pretty sure you will, in fact. Number 19 is a good problem. That's sort of like the swimmer problem. Elevator problem. Probably see one like that. No big secrets about what's on the exam. Okay, they won't be exactly like this, but they'll be very, very similar. Questions? Y'all want to work through some of those? Don't be bashful. Which ones?
Yeah.
Which ones?
19.
Okay, 19. A block with a mass of 5 kilograms moves on a flat surface. Force of 20 newtons causes it to accelerate with 2 meters per second squared. Remember, we talked about this today. If I have 20 newtons acting on a 5 kilogram block, well, gosh, I should be getting 4 meters per second squared out of that force, but I'm not. I'm only getting 2. And that means that there's another force, and I know that force is friction. Here it tells me. So to find that frictional force, I say the sum of the forces equals 20 minus Fk is equal to the mass, that's 5 kilograms, times the acceleration, which is 2 meters per second squared. So Fk is equal to 10 newtons. And that gives me a net force of 10 newtons, which would give me 2 meters per second squared. Now, but that's not the answer, right? In fact, 10 is not over here. I'm looking for the coefficient. And I know that Fk is mu, okay, times the normal force. So mu then is equal to F over Fn. And I don't know Fn, but it's just a block on a flat surface with no vertical forces, so I know that Fn is what? It's the weight. It's equal to 5 times 10, or 50. So Fn is 50, so it's going to be 10 over 50, which is equal to 0.2. Yeah, so my mu is coefficient, the Greek letter mu, not m, it's mu, it's like a u with an extra little tail on the left, is F divided by the normal force. Little f is 10 newtons, we found that by applying Newton's second law. And then the normal force we just know is equal to the weight.
So what, how you know? So yeah, that's Fk.
Yeah, the upper one is, and the numerator is Fk. All right.
Nope.
If y'all came in late, make sure you stop by and see. I know several have come in, but I sort of forgot to do it, so I get sure you get your name ticked off. Okay. You hear me, John? John? Make sure you see me at the end, just to get you clicked off. All right. Let's look at these others. What else, y'all? Diana?
You said it and I just...
On this exam? Yeah, what?
The one we just did. You said it and I just didn't hear you. How'd you get the 50 again for F?
Okay, so the 50 for Fn is because it's on a horizontal surface, and there are no other vertical forces. So that means that the normal force is equal to the weight. The mass is 5 kilograms, so the weight is 50 newtons. Hopefully you want to make those connections really quickly, that you have to sit around and think about, gosh, what's the normal force for this? That it just clicks with you, that it's equal to the weight. Now that wasn't true on that previous problem that we did. That wasn't true on this problem, because you had that extra force pulling up. And so the normal force here was equal to the difference in these forces. It was equal to 40 minus 50 sine 30. Yay? All right. You want to do incline plane?
Yes.
Yes, why not? All right, let's do this one. So when you come to these, they might have friction, they might not have friction. And this one, it's a smooth incline, so they're a little easier when they don't have friction, because you don't have to worry about the normal force. The 2 kilogram mass is pulled up a smooth incline by a rope, so it accelerates at a rate of 1 meter per second squared. What is the tension in the rope? So let's just draw our forces. There's our weight, Fw. There's our tension, Ft. And there's our normal force, Fn. And it's accelerating in this direction. And then we can draw our coordinate system. Oh, let's go ahead and, no, I'll just draw our coordinate system. So on our coordinate system, we have Ft, Fn, and then our weight breaks into two parts, Fw cosine of 60 and Fw sine of 60. Hopefully this is second nature to you right now. You don't need to think about what angle do I use and what trig functions do I use. But notice I took the complementary angle, that's 90 minus this angle, and I use cosine and sine for my x and y components. Now I look at the x direction. Some of the forces in the x is Fw cosine 60 minus Ft. That's equal to the mass times the acceleration. Same procedure, right, every time. It's like a broken record. We do the same stuff every time. Now I'm to step 5. After applying Newton's second law, I solve for Ft. So Ft is equal to Fw cosine 60 minus Ma. So that's, what was Fw? 20 newtons. That's 2 newtons times, or 2 kilograms times 10 meters per second squared. Cosine of 60 minus 2. Okay, and this is where you got to be careful. Make sure that you get the sign of the acceleration right. And since the acceleration is to the left, that means the acceleration is -1. That's going to be sort of what tricks you up most of all. What is that? 10 plus 2 is 12. So A is right. I didn't put 8 here, but that's a common thing. I should have put 8 as an option too. You see, because if you didn't count this as a -1 right here, it would have given you 8 instead of 12. So be careful. Check your signs. I mean, be very careful of your signs, especially for that acceleration, because it might be a negative acceleration. Don't think about, is it going up or down? Think about, is it going to the left on the x-axis or to the right on the x-axis? Remember, we're rotating that coordinate system. Now you got to stick to that coordinate system once we choose it. Okay? Not meant to be tricky. It's just meant to make sure that you're careful and that you know what you're doing. But it is a little tricky, isn't it? Yeah. And a little bit mean? Like, it's a little bit mean. Yeah. Let's just agree. All right. I'm a little bit mean. Am I a little mean? No, I'm not mean. Am I?
You're a little mean.
I'm a little mean.
I feel like a little bit of sadism in this. It's a little bit of sadism.
No, not mean. Not mean. Okay, you had your hand up? Or- No. Questions? 15? 14? Let's see, number 4. I don't know if I go back that far here. I can get it off the internet. Oh, yeah. Oh, good. Let's talk about some projectile motion. Yeah, this is a good one. We haven't really done this one in class, but we've done one similar like it. A cannonball is fired horizontally at 10 meters per second from a cliff. Let me just draw a picture. That means I'm talking about this thing. And I want to know its speed 1 second after being fired. We did one similar to this today. We did one where we found the velocity at the end. And remember, we had to find both vectors. This was a little bit different because it's not getting to the end. So it's actually a little easier because I don't have to find, how long does it take to drop. I just want to find what is the speed here where t is equal to 1 second. And I need to find the x component and the y component. The x component is easy because I already know it. Vx is equal to 10 meters per second. Because it's given, it's fired horizontally, so that is my v naught x. And since it doesn't accelerate in the x direction, v naught x is equal to vx at all times. It's always the same. Vy is a little more complicated. I say Vy is equal to V naught y plus Ay times t. That's 0 minus 10 times 1 second. So it's equal to negative 10 meters per second squared. Or meters per second, excuse me. So I've got 10 meters per second here and 10 meters per second here. It's going to be the square root of 10 squared plus 10 squared. You might not be able to see that the way I have it drawn, but I have a 10 unit vector and a 10 unit vector, and I'm looking for that vector. That'll give me the speed. The red vector is the total speed. So that's square root of 216, I think. Is it 14? Okay. Sorry. Good question. Yeah. Okay.
So wait, you got the square. You just took the square root of 10 and 10 squared, 10 squared.
Right. Using the Pythagorean theorem to find the resultant of these two of the x and y components of that vector. Now we're getting good at vectors, aren't you? This is good. It's good. Number 11. Yes. Same one. Oh yeah, this was tricky. Students did not like this stuff at all. You probably won't see one like it. Let's talk about it because it's useful. Equal amounts of time go between these two. So we can call this, say, t equals 0. All right, yeah, no, we just have, it doesn't really matter what the t is. We just have equal amounts of time between here and here and here. These are all equal amounts of time. And so I want to know how much time, or what is the distances for n and o. So I'm looking here at y. Y is equal to 1/2 at squared. So here, I know this is 2 meters. At this point, I've doubled the time. And if I double the time, what do I do to the displacement?
You double it?
I quadruple it because it's squared, right? If I double the time, I quadruple it. So if this is 2 meters, this is 8 meters, because that's quadrupled, right? 2 times 4. And so it's either going to be either B or D. And then the next part is I triple the time from the first part. I have 3 increments of time. I triple it at 9 times. So initially it was 2, now it's going to be 18. That's a good question for you to think about, but you're not going to see a question exactly like that. Would you have missed that one?
Yes.
Yes,
Yeah.
absolutely.
Yeah, the whole class, that question, I remember.
Throw it out.
It caused, I'll throw out question. They should have been on this. They know this, right? They knew this.
You really are mean.
But you won't have that. You won't have a question like that. Okay? Matt, you asked that? Yeah. All right, what else? Yeah. There's always one question that's just sort of like, it's like My wife, when she was a kid, they used to make these rolls at Thanksgiving. They'd make the crescent rolls, but they put marshmallows inside of them. Not inside of all of them. It was just like if you were lucky enough to get that one with the marshmallow, it was like a little treat. Did you ever do that? Put marshmallows inside your crescent rolls?
Basically, reverse Russian roulette.
No, they're good is the thing.
Nice, like I said, it's reverse Russian roulette.
Right, yeah. And so like these questions are sort of like that. They're sort of like marshmallows inside of your crescent rolls. It's like, thank you, this is really good. All right, what else? Yes. Okay, yeah, so this one's similar, but it's good to look at these. So here I wanted to know the normal force. And first of all, I know the normal force is going to be less than the weight. And I know the weight is 100 newtons, so I can get rid of D. So I know it's either A, B, or C. Draw my coordinate system, like that. Draw my forces. I'm going to go and resolve this force, F cosine 30, F sine of 30, Fn, and Fw. So those are the forces that are acting. And if I want to know the normal force, I look at the y-axis. I say the sum of the forces in the y-axis is equal to Fn plus F sine 30 minus Fw. And I know in the y-axis it's not accelerating in that direction. It's not moving. So that's equal to 0. So Fn then is equal to Fw minus F sine 30. So that's 100 newtons. That's 10 kilograms times 10 meters per second squared. Minus F, which is 20. That's given in the problem. Times sine of 30, which is a half. So it's equal to 90. And then, I could ask an additional question. What is the acceleration? In fact, was there another question about this?
It's about
Oh, yeah. So, yeah. So if I needed, if there was friction, and listen, you do have some series problems, but I tried to keep them independent. Like on this problem, if you got the first one wrong, you'd get the second one wrong too. But you do have some series problems where we have one after another. But I'm pretty sure I kept them independent of one another. So if you got the first one wrong, you don't necessarily get the second one wrong. I'm pretty sure I did that. I'm 90% certain I did. 98% certain I did. All right, so what am I doing? Oh, I'm adding in friction. So if I have Fk here, what do? Well, I say the sum of the forces in the x direction is F cosine 30 minus Fk, and that's equal to MAX. Well, I know F, and I know M, and I want to know A, but I don't know the kinetic friction. But I can find it really easily. I know that Fk is equal to mu k times the normal force, so that's 0.1 times the normal force, which is, we just found it to be 90. So it's equal to 9 newtons. So I got F cosine 30. That's 20.
UK.
Mu k is given in number 21. So number 21, the previous problem, it says the coefficient is 0.1 right here. What rate does it accelerate? So I have 17 minus 9 equals 10 times A. So it's 0.8 meters per second squared.
So it's UK, alright, it's UK, I think.
Right, so here I gave you mu k. You had to use your normal force from the previous problem to find what is the kinetic friction. So I'm pretty sure that I didn't have them dependent on one another, but if you do come into that, make certain that you have the first one right, if it does depend, okay? Because if you got the first one wrong, that means you missed 2 questions, right? So be careful. I'm pretty sure I didn't do that. Yeah.
Why is US always greater than
Mu, it's just the way it is. It is.
So just
Yeah, it's just the way, I don't know, that I think it has to do with like the molecular interactions of the materials. That when they're stuck to one another like that, it's just the electrons are stickier or something. I don't know exactly why, I think that's why. Okay? Did you want to, do you really want to know, or do you want to know for the test? I can find out.
No, like I mean it asks which is true about friction as US, that's a question when US is greater than UK.
US is always greater than
Right.
UK.
I'm just trying to see it.
The way that
from, sorry.
Well, the way that I remember it is because it's just harder to push things when they're not moving. But then after you get them moving, it's a lot easier to move them.
They have a question like that, it's similar on fall 2017, and that
What?
it's asking about the anti-lock brake.
Oh yeah, we didn't talk about anti-lock brakes
So
in the
it's not
class,
gonna
so you're not going to see anti-lock
What
brakes.
about the gravitational one where you ask if like the gravitational force is bigger on when moving versus or something?
No, we didn't. I said no universal law of gravitation. That would be sort of like that. Is that all for you? Ross? The 17 is F cosine 30.
Okay.
F is was given in the problem. It's 20. That's this force right here. And then cosine 30 is 0.86. So 20
Okay.
is 0.86.
Oh, okay.
Yeah. That one?
How
That
do
one.
you know if you need to find the angle?
When you're dealing with an inclined plane.
So you can always track the angle if you have an inclined plane.
Yeah. And a lot of textbooks, they don't do that. You use the angle, but then it flips your cosines and sines around. But I think it's easier. Just take the complementary angle anytime you're dealing with an inclined plane. Okay? With an inclined plane, if I have an inclined plane like this, the acceleration down the inclined plane is always equal to g. If this is, say, 30, it's always equal to g cosine of 60. It's always g times the cosine of a complementary angle. The acceleration, if there's no friction. Y'all probably have seen that. You might have run into that. I know it was in the book, but that's always true. As long as you don't have friction or any other force. It's just an object on an inclined plane. I'm not saying you memorize that, but if you're doing like the MCAT or something, you should probably memorize that. Okay? You have a question for me?
For number 21 on file 15, explain why the normal force is less than m times g. That one.
Okay, yeah. Because the normal force is the component of the weight. And components are always less than their force. Let me show you. The normal force is a component of the weight. Right? You hear what I'm saying? So if my normal force is here, Fn, my weight is here. And so if I draw those on a coordinate system like this, I have my normal force here, and my weight, Fw sine of theta, is there. So my normal force is equal to the weight times the sine of theta. And the sine of any angle is always, all of your trig functions are always less than 1. Your sine and cosines are. The sine of an angle or the cosine of an angle will always be less than 1. Or equal to sine b. Does that answer your question? Can you ask it again?
Remember where it is. Like, the weight has two components to it, right?
Right, the weight has two components.
Okay, so then why wouldn't the normal force be more
more than that since it's only one.
And that makes sense. No. I'll just remember that.
No. The normal force, let's say that the normal force is equal to the force weight times
Yes.
theta. And so, like if this is a big number, and you multiply it times a fraction, then this is going to be less than a big number. About half of you are seeing that? About half. You seeing okay?
This is like very similar to like one of the first questions that we did, like it was number 26 on fall 2016 where we said like as the incline increased, like the normal force dropped.
Mm-hmm.
So like it's a similar concept.
Yeah. Yeah, because the normal force is equal to the weight here, but as it gradually goes up and up and up, the normal force decreases until over here the normal force is 0. What happens to the frictional force here? Assuming that the object is moving, the object here is moving, it has a kinetic frictional force that's acting down the inclined plane. What happens to the frictional force as this increases? Are you sure?
It decreases.
Why does it decrease? What the frictional force is proportional to the normal force, right? And so if the normal force is decreasing here, that means the frictional force is also decreasing. You follow me? If it's moving, if the object's moving.
Like you said, like if you have something and you hold it against the wall, then the normal force and the frictional force are equal.
No? So what I said there, if I have something and it's up against the wall like this, and I have a force that's acting on it, this force is equal to, this is not the normal force, this force is equal to the normal force. So F is equal to Fn. Now you have the frictional force is different here. The frictional force actually is acting up. So this is Fs and Fw is in that direction. So if I draw it on a coordinate system, it'll look like this. I'll have F in this direction, Fn in this direction, Fs in that direction, and Fw in that direction. So in order for that thing to stay suspended, this has to equal this, or otherwise it's going to fall. It's going to accelerate downward. Y'all getting me on this? Y'all see this diagram? You understand it?
I thought,
Wait, can I, hold on. Do y'all understand this diagram? You sure?
yes,
Okay, go ahead.
I thought the frictional force was always in the opposite direction of the force applied.
No. The frictional force is always in the opposite direction of the motion.
Oh.
All right, and so here are the direction that the object would tend to move. And so here, this thing would tend to move down, so the frictional force is up. It always keeps things where they are. Okay? What else, folks? Yeah. 16? I mean, fall 16, I mean. Is it this one? This one right here?
No, it's number 20.
Oh, number 20. You said that. Oh yeah, so you'll have one something like this. So first of all, you know if she's really 700, but now she's 800, that it's going up or down. It's going up. She feels heavier. That's why when you get in an elevator, it sort of feels like you're pulling down on you. So I know it has to be B, C, or D. Let's draw the lady. She has two forces acting on her. She has her weight, and then she also has her normal force. And what we're saying is that the normal force is equal to 800, and that her weight is equal to 700. And so we're saying that the normal force, 800 minus 700, is equal to her mass times her acceleration. And we want to find out what that acceleration is. Now, often I give you the mass and you have to find the weight, but here that's different. I've given you the weight, 700 newtons, and you have to find the mass. So the mass is 70 kilograms. So I have 100 equals 70A. So A is 100 divided by 70. I think that's 1.4, is it right? Well, it's definitely not 2. Yeah.
You want to press never mind.
Okay. Good question. You'll have, I don't know if you want, it won't be exactly like that, but a 1D problem where you're moving an object up in there. All right? Okay? Is that all for today, or more questions? I can stay another 10 minutes or so if we need. Yeah, Madeline? Yeah, of course. Yes. Give me just a minute. Okay, I have to log on. Which means I have. How many of you were not able to see your answers? Seriously, and how many? All of them? Yeah, will you email me?
The first couple works out, and then the last one. Just feel like it's there.
All right, you want to look at this one?
Look at the last question. 14.
Yeah. This one? Oh, is it just 3 options?
Yeah.
Yeah, so the frictional force is up the inclined plane. That's right. Right, because the frictional force is opposite the direction of motion. The frictional force depends on the mass of the object. Is that true? It does, because if the mass increases, that means the normal force will increase, and that means that the frictional force will increase as well. And if theta increases, the frictional force will decrease. If theta increases, the normal force decreases. Assuming that's true. All right? You see several questions like that, okay? So, like these, I give you several statements, you have to think through them. I know those are, when you're in the frenzy of an exam, that can be difficult. Take a big deep breath, all right? And think through those problems. I know I'm telling you on one hand, you better hurry, 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 hurry. And then on the other hand, I'm telling you, you need to stop. You gotta take a big deep breath.
One or the other.
Huh?
What she said, one or the other.
You need to do both. Like on those problems that you're really confident on, you just, no, you don't have to work on it. You don't even want to.
I think that you can.
What?
Simple errors. You have time to
Listen,
that.
y'all are like goldfish.
It's
We will get as big as the container allows. And I used to, one time I said for final exam, this was the craziest idea I ever had. I said, you can have unlimited time. I was there for like 5 hours.
please.
Oh, it was terrible. I mean, it was just a handful of students, but not most people left. Yeah, you get 3 hours, right, or 2 hours, whatever. I was there for
Maybe we could get somebody else to do something.
I think they didn't do very well. They were there for 5 hours.
And they didn't do it. First person to finish gets to pick up your kids at school.
Yeah, right. Let you yahoos pick up my kids. All right. Some of these others you want to look at? Number 10. Okay, this one's really just about knowing the language. Because the component of the weight is perpendicular. What is that? What do we call that? That's the normal force, right? Can I write on this? I don't know if I can.
Last time you could.
Yeah, it doesn't always work. The component of the weight is the normal force. And to find that, if this angle is 25, the weight here. The component is FW sine 65, 90 minus 25. So it's whatever that is, 226, I guess. Now how do I get rid of it? Okay, what else on here? I'll scroll through. Okay, yeah, what is the magnitude of the force that the swimmer applies to the wall? We worked through one similar. This is a good problem. I'm not going to try to draw a swimmer, but I have a 65 kilogram swimmer. I know the friction is 100 newtons, and I want to know the magnitude of this force. What is this force equal to? And I know the acceleration is in this direction at 6 meters per second squared. So just like we've been doing, sum of the forces equals ma. F minus 100 equals 65 times 2. Is that 130? So that's not right. What's the deal? Oh, 65 times, not 2, times 6. It should be a 6 right here. What's that, 360 plus 390? It's 390, is that right? So that's equal to 490.
Like 65 times 2, say?
No, 65 times 6. I made a mistake. This is the acceleration, and the acceleration is 6, positive 6. Okay? It's a good 1D problem. You'll have a problem similar to that. I'm pretty sure. Great. Yeah, that is great, right? Because now you know. Now you know it's like, well, I got it. Well, you knew before. It's a 1D problem. Oh, you're being serious. Great. Not sarcastic. All right. Let's see. Yes, 5, 6, maybe as many as 7 problems that are open stacks. In fact, some of these problems are actually, they're problems that are from my old test, so if you might see some that are familiar. All right, you want to look at the other one? Oh, okay, let's look at the projectile. Remember, there are 2 that are relevant for this test. Right, a lot of these are basic, sort of our putative, our standard problems. Like this is the one where you're going out horizontally. This is the one where you start from the beginning and go to the same height, right, like that. You need to know how to do all those. This is the one, this is beginning and ending at the same height. This is just a 40, you know, it's 45. It's a horizontal. This is like one that I worked today where you're starting here and you're landing somewhere up here, but I give you the time. We worked through all of these today in class, but I can certainly work through some more, or ones like these today in class. Those are good examples. Like I said, you hit that first page, and you got 5 projectile motion problems. So don't freak out. Just make sure you know how to do them. Make sure you can do these basic ones and that you know them inside and out. That'll make you feel much more confident on the exam. All right. Any questions about these, or y'all good to go? Good to go. You don't know how to do them. All right. See me if you were in a little late, okay? So I can get your name marked down.